So before I move forward, I have a question for the audience. Does anybody know what was the first command introduced in Unix for process isolation? You're right, that's change root.
Nice.
And that's what I think we see today in all the containers, is the processes and the virtualization. So thank you. So let's move forward. Introducing myself, I am expert engineer at Discover. I work on to both hybrid cloud environment setup as well as the application development. And I have my fellow architect Aman. So Aman, why don't you introduce yourself?
Yeah, hi everyone. My name is Aman Sardana. I'm the expert application architect at Discover, which is now part of Capital One Financial Services. So let's move on with the presentation today. So before we discuss the hybrid cloud itself, right, and the challenges and the mitigation strategies, let's first understand what is a business critical application. So in order to relate better with business critical application, let's just take an example, right, within the payments domain. So we all love shopping, right? We either do shopping online or we go to a retail store. So it all starts with a customer either swiping or tapping the card, and then the payment information is captured, which is sent to an entity known as acquirer. Acquirer is the one that has a relationship with the merchant to acquire the transactions and send it to a payment network. Payment network could be either Visa, MasterCard, American Express, Discover, or there are international payment brands like JCB, China Union Pay. So regardless of like whatever payment network processes the transaction, it is sent to an issuing bank. Issuing bank is the one that authorizes the transaction, send it back to the network, and it takes the route back to the merchant. So if the transaction is authorized, you walk away with the goods or your online transaction is completed. So this seemed like a simple process where you swipe the card and you walk away with the goods. But as you can see here, there are so many entities involved, and especially within the payment network, it's a complex system that runs, that processes the transactions. Now, just to relate it better, within Discover, we have what we call as Discover Network, which is a domestic network, and then we have an international payment network, which is known as the Diners Club International. So it's a two-sided platform. On one side, we are connected to the acquiring merchants. On the other side, we are connected to the issuing side, right, the card issuers. Now, from the volume perspective, we process about like 5 billion transactions annually. The availability of the platform is 5 nines, which means that we cannot go down for more than 5 minutes, 26 seconds in a year. We process hundreds of billions of transactions annually, and the response time is less than 1 second. So whenever you use your card, it mostly works, right? So it's a mission critical system for a company which processes like billions of transactions and a huge volume of like fund movement. Now, there could be other examples like open banking, batch processing like settlement, real-time fraud monitoring. So these are all the examples of critical systems in payments domain. And likewise, in other domains, there might be other critical systems as well. Now, just to kind of like relate it better, let's talk about like what is a hybrid cloud, which I think we all know. Just a quick recap for everyone, that a hybrid cloud is basically when you have some servers that are running on-prem, and then you have some compute that you run in cloud. And especially with critical systems, it's very important that you strike a right balance because you don't want to risk your business as well. Now, there are different models where either company go with infrastructure as a services, platform as a services, or software as a service. And it's important to understand that on-prem still plays a role in some of these financial institutions which are regulated. Service orchestration plays a huge role where you want to make sure that there is a seamless integration between on-prem and cloud infrastructure. Now, just to set some context here, there was a survey done by CNCF last year, which shows that 60% of the enterprises are still running hybrid cloud. So it's a real problem in the industry where a lot of companies are still dependent on hybrid cloud. When we look at the number of servers running on-prem, of course, I mean, there has been an increase in the number of companies that have got rid of their on-prem infrastructure, but still majority of the companies have on-prem presence. So it becomes a real challenge for these companies to make sure that they strike a right balance between on-prem and cloud and run their mission critical workloads in a seamless manner. Now, from the scenario perspective, there could be a company that is running on-prem. It has a non-containerized workload. Mainframe is still a reality. There are still companies running mainframes, virtual machines. And then they look at moving their infrastructure to public cloud. They have a lot of different options. Either they take the existing application, they do a lift and shift into a virtual machine in the cloud, or they might go with managed Kubernetes service or self-managed Kubernetes service, or they might not even go with Kubernetes. They might go with a managed container service like ECS, Fargate, and few others like offered by other public cloud provider. So as you can see here, a lot of different options companies have. Now, there could be a company that is already like quite mature on-prem. They have already containerized their applications on-prem, and now they are taking the journey to move to cloud. And they also have like similar choices. They can go with a managed Kubernetes service, or they can go with a self-managed Kubernetes service, since they are already running on-prem on Kubernetes. Now, there are benefits of cloud, as we know. I mean, it helps to mitigate the risk, especially for critical workload. We have a fallback option to come back to on-prem. If something happens in the cloud, we can still support our critical workloads. And then companies usually have a journey towards maturing their cloud, right? I mean, before they go cloud native. So there is a transition phase where they might be running in a hybrid mode. And then, and then there is a capacity burst, right? I mean, if there is a sudden surge in payment transactions, we can always add more compute, and it comes with a lot of flexibility in the cloud. So now I'll hand it over to Vijay to take us through some key challenges in hybrid cloud environment.
Thanks, Aman. That was good. If you look at the hybrid cloud is here to stay for a while. It's not going away just because of regulated environment and everything. So what I will take you through is that the major challenges we see in the hybrid cloud environment, how we manage like on-prem as well as the on-cloud workload. But at the same time, like there are situations where we have to strike the balance. So we identified kind of 12 major challenges. Some of them are critical. We must mitigate, be very wise about handling those. Some of them are like medium or low, where cost factors are probably the managing the DevOps specific items. So starting with the first one, it's an increased network complexity. Then going to the next one, which is complex service discovery. Moving forward, cluster management, customization, continuous security overhead, compliance requirement related problems, network latency issues, application integration constraints, DevOps effort increment, and then DR process challenges, high availability risk, monitoring and tooling related overhead, and finally increased business cost. Increased business cost is something business already is made aware that they might have duplicate cost, but again they have to handle it because of the depending on the tooling and the resources we use. So we have grouped them as we provide the more details around these challenges. We have grouped them into 4. So there are 12 challenges, so we'll be going in the group of 4, so we can explain some of the mitigation strategies. So the first one is increased network complexities, where we are talking about hybrid networking, where you have existing on-prem clusters or the VMs or whatever, and then you have now new network where you have to make sure that hybrid networking works. Then we have pod IP overlap. So if you have done the good job in the networking space, because Kubernetes is probably also the flat network, so in that case you don't want IP conflicts, so all those you need to look at. Then global routing limitation, and again the net traversal issues. So those are the things which we think that in terms of network that needs to be managed. Going to the next challenge, so that is complex service discovery. Now you can look up into the network itself and going back and forth between the on-prem and the data center just because of the service discovery, whether it is DNS lookup, internal or external. So all those things probably are still coexist, and then we have to look at like cross-cluster communication between on-prem and the cloud, DNS lookup. There could be caching issues which you may encounter because of the frequent IP rotation, and then finally the load balancer integration, which could increase the latency of the service. Moving to the next one, which is the customized cluster management. So you will get into the operational complexity of managing the cluster on-prem as well as the on the cloud. Then you have the lack of unified control plane, which may be because of the fragmented management of the control itself. And then Moving to observability, which means that you may not have single pane of glass unless you've got it into a tool which can do both on-prem as well as the on-cloud implementation. Then you have resource complexity, and then again finally the centralized control, or the policies which probably can manage both on-prem and on-cloud resources. Next one is continuous security overhead. So especially in the regulated environment, the security is one of the major criteria which must qualify before we deploy anything in production and run for our customers. So multi-zone trust management, network-related security, internet exposure, and the secret management specifically, because now you had the secrets which you are running used by all the workloads on-prem. Now how would you share on the on cloud, whether what kind of policies or tooling you will use. And then finally the network packet inspection, so going traffic back and forth between on cloud and on-prem, how to manage. So with these first four, I will ask Aman to go provide some recommended mitigation strategies.
Yeah, so thanks Vijay for going through the first four challenges. Now let's take a look at like how we can minimize the impact of these challenges in real world, right? So there's no silver bullet that we can completely eliminate all these challenges, but we can help ourselves to kind of like make our lives easy by applying some of these mitigation strategies. So for the network complexity, there are different solutions like software-defined WAN solutions, overlay networks, etc., that can be used to have like a seamless integration between on-prem and cloud. Using cloud-native network services like, for example, AWS Transit Gateway provides a dedicated MPLS connectivity between on-prem and cloud. And then standardizing the network configuration could be another way to help alleviate some of the network complexity concerns. For service discovery, using service mesh solutions like Istio, using cluster gateway, where it provides a seamless integration between the multiple clusters, either could be running on-prem and in cloud, or it could be multiple clusters running in multi-cloud environment. It helps to make sure that the service discovery between pods works seamlessly between different clusters. And then having overlay networking solutions to simplify the cluster connectivity. From the cluster management standpoint, since there could be an on-prem cluster and a cloud cluster, it helps to like build some automation capability using Terraform, Ansible, and then having a unified control plane, which I'm sure like a lot of us have just seen some of the vendor products displayed here as well. Also, like a lot of public cloud providers have their own like unified control plane that they provide, or there are like from Tanzu or from Red Hat has its own advanced cluster management that can be used. Now, from the continuous security overhead standpoint, having federated authentication and encryption would help, and then using some secret management tool like HashiCorp Vault. So standardizing around like one consistent security platform helps in our multi-cloud deployment scenarios. And then making sure that we are validating the configuration for security is also very important in multi-cloud, especially for the regulated industries. So I'll hand it back to Vijay to take us through the next set of like 4 challenges in hybrid cloud.
Thanks, Aman. So first 4 were critical. Now we have a few more critical ones. Then we move to the medium, and then finally the easy one, which is the cost. So the added compliance requirements. So operational sovereignty, like every company wants to have the visibility around what is happening on-prem and what is happening on cloud. So visibility and control and operation becomes essential, and then it becomes challenging as well in the hybrid cloud environment. Data sovereignty, data localization requirement, like geographical requirement, may influence that how you manage the data, which means becomes challenging into hybrid cloud environment, requires the correct policies. And common rules across the cluster becomes essential, because the data is flowing back and forth between cloud as well as the on-prem workload. So make sure that those policies consistent. That becomes challenging to manage. Finally, the compliance. So GDPR in European Union, PCI payment related to payment data security, and then HIPAA for the healthcare, and then PSD2 is Europe Payment Service Directory. So all these regulations influence how you manage the data, and as well as the data flow processing. So in that case, those become challenging into hybrid cloud. The next one is variable network latency. So this one is a simple one, but very difficult to implement. So a VPN over public cloud, that's probably initial approach a lot of small organizations do take, but as you grow, in variable network latency may bite because of the SLAs on the customer side. So in those contexts, that becomes challenging to manage the network latency itself between hybrid cloud. Then geographical separation. So that's where your data center is hosted and what kind of which region you are deploying your cloud resources. That becomes increasingly important. Then quality of service rule implementation, network packets prioritization also becomes essential for the services which needs the quality of service better than the other. Finally, the application integration constraints. So now you have mainframe, you have VMs on the on-prem running fine. Now when you go to cloud, you just can't do everything lift and shift. So you will have to have some modernization in that, and it becomes difficult in certain cases to just quickly move to cloud. So in those cases, you look into that what applications, what services really need the actually not just re-architecture but also rewriting. So those consideration needs to happen. That becomes challenging because you can't have same code running on both. Dependency management, specific libraries and version, protocol differences and data synchronization. So even though you have tools for the data replication or back and forth between cloud and the on-prem, you still have the risk of either the losing the data or the not getting replicated on time. The final challenge in this group is increased DevOps efforts. So if you look at now, we have two environments to manage, on-prem as well as cloud. Now, you may have the single pipeline now for the on-prem, but when you go to cloud, you may need some custom scripts to actually manage the resources just because of the previous slide description, like how the same application cannot be deployed. Then you have the maintenance overhead, infrastructure as a code limitation, duplicate build effort, application portability challenges, and then finally the release version tracking, which is nothing but you have essentially got in most of the cases, two versions of applications. So I will hand it over back to Aman to provide some mitigation strategies.
Yeah, so thanks, Vijay. So now let's take a quick look at what could be the mitigation strategies for the last four challenges that Vijay went through. So for the compliance requirement, having some sort of like affinity, anti-affinity rules for the node placement would help, like in the scenarios where you want to isolate some of the workloads because of some of the regulatory requirements. Using open policy agent, especially when we deploy that on the admission controller, would help enforce some of the policies when resources are being accessed in the cluster. And using some scanning tools would also help in these scenarios. For the network latency, again, we cannot completely eliminate network latency. That's the law of physics. But then making sure that we have some mitigation strategies around using edge computing, having AWS Direct Connect that provides a private overlay network, MPLS connectivity that gives us a reliable connection would help. And then using tools like Calico or Cilium that will help implement some of the quality of service rules. From the application integration standpoint, containerizing the application definitely helps, and then making sure that you also architect your application by decoupling as much as by event-driven architecture would help in these scenarios. From the DevOps effort standpoint, using templates and custom modules would help, and standardizing some of the deployments using OpenShift or Rancher for on-prem and public cloud brings the abstraction layer that helps managing the multiple cluster scenario easier. So I'll hand it over back to Vijay to take us through the last four set of challenges.
Yeah, I promise that there will not be a lot more back and forth. So this is the last set. So challenge 9 is a complex DR process. You can imagine now the on-prem, you had the DR process written and it was working for the years. Now you move to the cloud and now you got the new DR process. So there would be different DR process for sure, and then standardizing them and making the single DR strategy becomes challenging. Then you have a strict RTO which is already defined, and now with the cloud and on-prem, data going back and forth, recovery time, and then also the recovery point for the data, those could become challenging. So that could increase the data loss risk. Then automated failover and then testing of the failover itself becomes a little bit challenging in this situation because of how the tooling is currently available. And finally, the people skill set and responsibility, which is now we are handling the broader set of the environment, so which means that the people need the broader skill set. Either the same pool of the resources or the people need to upskill, or probably you need to get the new people who can manage the environment. The high availability risk is the infrastructure failure, which is if you have not implemented properly, then you could get into the infrastructure issues. Then cross environment dependency. So if you have deployed an application on the cloud and then it is dependent on the on-prem services or vice versa, then if one service fails into one environment because of infrastructure, it get in the other service on the the other environment, which could be on-prem or on cloud, could get affected. Then you have a scaling limitation, which is you have a different scaling pattern. So I'm sure that on-prem you have very simple, probably horizontal scaling or probably fixed number of servers, but in cloud you are looking for containerized workloads. So a scaling limitation probably on the on-prem might be difficult to manage. And then finally, complex and prolonged recovery and the data loss risk because of the data replication rate. The next one is monitoring and tooling. So now you see that all the monitoring and tooling available in on-prem may not be exactly working into on-cloud. So which means that you need to have a diverse set of tooling. And then for the real-time observability, business needs to spend more, which means that high infrastructure cost, and then duplicate monitoring is, and again, going back to the previous slide where the people may not have the same skill set, so you need the specialized expertise to actually manage utilize those tooling, which means that there's additional cost. And finally, the technical debt, which is nothing but you will have to do the patching and then maintenance of those infrastructure, or probably whether it is image or whether it is the VMs or whatever it is, there is additional cost around that. Last one is, with all this, increased business costs. So infrastructure cost, which is maintenance of the the environment itself, there is additional cost, and then sometimes that may lead to, if you have not architected well or you have not analyzed well, then you could have the additional infrastructure provision, which means that you have the underutilized resources. Then you have additional licensing cost, compliance and operations. It goes back to the previous point where on cloud and on-prem may require the compliance controls, and that's where the cost and the people around those that could go up. And then finally the vendor lock-in. So if you from on-prem you go to cloud and you have just one vendor, then probably pricing negotiation power is low. With that, Aman, if you can provide the mitigation strategies for this.
Okay, thanks, Vijay. So let's quickly wrap up on the mitigation for the last 4 challenges. So for the disaster recovery, it's important to have a unified DR strategy. And it's not just about defining the strategy, but actually being able to simulate the disaster recovery scenario using tools like Gremlin or Chaos Toolkit is really, really important. Like we from our experience, that's not negotiable. From the high availability risk standpoint, using service mesh would help in the scenario where companies are looking for high availability and mitigate some of those risks. And using horizontal pod and vertical pod auto scaling, and using cloud native services like AWS auto scaling groups helps in dynamic scaling. For the increased monitoring and tooling, consolidating on standard observability tools like Datadog, unified telemetry would help. And then finally, for the increased business cost, keeping an eye on the cost using services like AWS Cost Explorer, and using auto scaling capability. And lastly, like minimizing the license cost using open source with containerization would help. Now, with all these challenges, let's try to sum this up, right, in a nice kind of like visual. So as you can see here, a company, regulated company, might be running all the infrastructure in data center. So they have a mix of both VM workload, as well as they might be running a few components in cloud, in on-prem, in containers. And now they set on this journey to start hosting in cloud, hybrid cloud. And they might set up a VPN connectivity, which again comes with its own disadvantage. It's not very reliable. So as they are moving their workload, so they start with putting their product A into cloud. And then because of all these latency issues, they start understanding like what can be done next. So they come up with AWS Direct Connectivity, which provides MPLS connectivity between on-prem and public cloud, which of course provides benefit of like enhanced security, reduced latency. But then as you see here, as the company matures in their cloud journey, now they are looking at other products that will be hosted in public cloud, which of course give some low latency path between product A and product B, but then there are some additional high latency path that gets introduced because product B itself has some internal dependencies. And the journey continues, right? I mean, now there's a product B component 2 being introduced, and there's a product C that is cloud native, and it just kind of gets so complex, right? It's really hard to manage. And then as we discussed, right, bringing service mesh like Istio Gateway would help resolve some of the challenges that comes with this complex environment that you see here in this one visual. So with that, I will have Vijay just conclude today's talk.
Yeah, thanks, Aman. That was a good picture. So one thing which I want to tell that in the previous picture on the right side on the cloud, when you move from on-prem to cloud, or in either case, try to run your workload and then the communication between the two workloads as local as possible, wherever it is possible, so that you can eliminate at least minimize the latency. Now, from the key takeaways, we are from here. So, infrastructure modernization perspective, modernization of the infrastructure is essential, but you have to take care of the other aspects which we described here to make sure that we have the optimal performance. Security and compliance is also essential. So, which means that addressing security and compliance while maintaining the infrastructure, resilient infrastructure is essential. And finally, the resiliency of the system with the right people, right skill set, and a right set of processes probably will help you navigate hybrid cloud challenges successfully. Thank you.
Yeah, thank you everyone for your time here.
Any questions you have, sir?